Hi folks, this is Calc 3, Checkpoint Quiz 18. Number 1, we're given a two-dimensional vector field. And part A asks if f is conservative. And so we have this little theorem that we're going to use. If f is a two-dimensional vector field, so we're going to let m be the x component and n be the y component, where m and n have continuous first partials in an open disk, then we have the following check for conservative. F is conservative if and only if my at xy equals nx at xy for all x and y in that open disk. So let's apply this criteria to our field f. The m is the x component, so mxy is 3x squared y squared, n is 6xy. So let's look what my is equal to. You take the derivative of this, you get 6x squared y. This is continuous on the entire plane. Let's look at nx. That's 6y. This is continuous in the entire plane. Are these things equal for all x and y? Nope. They're not equal. That means that f is not conservative. And that's it for 1a. Now for part B, we're asked to find the divergence of f. That's del dot f. So del dot f, what's that going to be in this case? Well, since f is a two-dimensional vector field, we're going to use the two-dimensional differentiation operator. Partial with respect to x, partial with respect to y. I'm going to dot that then with our field. 3x squared y squared, comma 6xy. Now remember, we abuse notation here. When we quote-unquote multiply the x components together, what we're really doing is taking the partial derivative with respect to x of the first component. And then we add that then to the partial derivative with respect to y of the y component. So this gives us 6xy squared plus 6x. And that's the divergence of f. So remember, the divergence of a vector field gives you a scalar function. This is a function of two variables like we studied in chapters 13 and 14. That'll do it for number 1.